In this lesson, we're going to be talking about fractions, specifically reducing fractions, multiplying, dividing, and then adding and subtracting fractions. So the first thing we want to do is reduce fractions. So there's a couple ways of thinking about this. One way of thinking about reducing fractions like 28 over 42 is to break 28 into some prime factors, or at least some factors that you know, even if you don't know the prime factors. The factors of 28 could be 7 times 4. The factors of 42 could be 7 times 6. Now 6 and 4 can both be broken down again, but if you're just trying to come up with something that you know, 7 and 4 might be the first thing you think of. So 7 and 7 can reduce, and then I'm left with 4 over 6. Now 4 can be broken down to 2 times 2, and 6 can be broken down to 2 times 3. And now the 2 and the 2 can divide out, and I'm just left with 2/3. Now that's not the only way that I could reduce these fractions. Let's try to show you another way. So I could just divide the top and the bottom by a common factor that I know divides both. 28 and 42. Now 28 and 42 both divide by 14. But I'm guessing most of us don't know our multiples of 14 all that well, but we might notice that they can both divide by 7. If you notice that, and you just divide the top by 7 and the bottom by 7, and that gets me 4 over 6, and then you can notice that 2 and 4 can also reduce by 2, and that gets you 2/3. Now if you notice that it could be divided by 14 right away, more power to you. I'm just guessing that a lot of us don't already know that. Okay, so on the next one, 90. 90, if you're going to write them out as the prime factors, could be written as, let's see here, 90 can be broken down to 3 times 30, 3 can be 3 and 10 can go again into 2 and 5. So if I wanted to break it all the way down, I could do 3 times 3 times 2 times 5, and the bottom 39 can be broken down into 3 times 13. So if I would have done that on the first problem, I wouldn't have had to do it twice. Okay, so I mean that makes sense, but if you didn't do it, that's okay too. Here, only the thing that divides is the 3, and that's it. So anything left that I have in the top, 3 times 2 is 6, times 5 is 30 over 13, and that's my final answer. Now if I wanted to do it another way, I could have just noticed that both the top and the bottom can be divisible by 3. So divide by 3 and you get 30 over 13. That also works. 34 over 30. 34 is 2 times 17, and 30 is 2 times 15. And notice that the 2's divide nicely, and I'm just left with 17 over 15. If I wanted to do it another way, I could have taken 34 over 30 and notice that they both are divisible by 2. And that leaves me with 17 over 15. Now notice 17 and 15 can't go any further, so that is completely done. Notice our next problem has variables in it, x's and y's. How exciting. So 56, if I want to break 56 down, 56 is 7 times 8. 8 is 4 and 2, 2, 2, 2, and then the 7. So if I break this down, I'm going to get in the top 2 times 2 times 2 times 7. Then I have x squared, which is x times x, and then y. Now if I want to do the bottom, 60 can break down into, I don't know, how about 3 and 20, 4 and 5. So the bottom I have 3, a 2, a 2, and a 5. I have 1 x and 2 y's this time. I think this is probably the most efficient way when you have variables, is just to write out the prime factorization. So the 2's divide out nicely. Another 2 divides out nicely. One of the x's divides out. One of the y's divides out, and I'm left with 2 times 7 times x on top, and 3 times 5 times y on top, which reduces to 14x over 15y. Our next problem is very similar. I'm going to do it the same way. Whenever there's variables, I want to do that way. So let's talk about 30. That's 5 and 6 and 2 and 3. So we have 5 times 2 times 3 times 5x's times 5y's. On the bottom, 26, that's 13 times, that's it, 2 times 13. 13 is prime, so you can't go any further. I have 4x's and 1y. Let's see what divides. A set of 2's divide, one set of x's, another set of x's, another set of x's, 4 sets of x's, and 1 set of y's. In the top, I'm left with 3 times 5, or 15. I'm also left with 1x, it looks like, 4 y's. In the bottom, I'm left with 13 and no other variables, so we are done for that one. Next, we'd like to multiply fractions. When you multiply fractions, you simply multiply the tops and multiply the bottoms. So let's show you a couple examples. 1 times 7 is 7. 5 times 9 is 45. And 7 over 45 doesn't reduce, so we're done. The next one, we have negative 2/3 times 5/7. Multiply the tops. First of all, a positive times a negative is going to be a negative. We learned that. 2 times 5 is 10. 3 times 7 is 21, so negative 10/21. 10/21 doesn't have any common factors, and so we're done. The top and the bottom can't divide by anything common. And the next one, I have 3 times 8, which is 24. 4 times 9, which is 36. Now this one can reduce. So the top can be divided by 12 and the bottom can be divided by 12. If you didn't notice 12, you could have done 6 and then you would have to do it again by 2. But if you notice the larger number you can divide commonly, then the faster you're going to be able to reduce. So that reduces to 2/3. Next, negative 7x over 2 times 5 over 14x squared. If I just multiply the tops, I'm getting negative 35x. Then I just multiply the bottoms, I'm getting 2 times 14, that's 28x squared. Now I can reduce this. The way I'm going to reduce it is use the prime factors. So 5 times 7 is 35. 28 is 4 times 7 times x times x. Now I know 4 can go down even further, and you could if you wanted to, but I noticed that it wasn't going to reduce, so I didn't bother doing it. On the top, I'm left with negative 5. On the bottom, I'm left with 4 times x, or 4x. So multiplying the top, multiplying the bottom, and reducing totally works. But if the numbers are large, then it becomes quite cumbersome to multiply first, because it gets really, really big. Let me show you an example of what I'm trying to talk about. So if I try to multiply the numerators and multiply the denominators and reduce, I have 18 times 35, which, seriously, I don't want to do that in my head. I went ahead and used a calculator and got 630. I don't really want you using calculator, but you'd have to multiply longhand, which we kind of aren't here. So I have 630 over 180, and that's actually like huge. Now I could reduce by, I'm going to first divide by 10, because I can divide by 10 really easily and get 63 over 18. Then I can divide again by what it looks like 9, and that gets me 7 over 2. So that is my answer, 7/2. But I had to go through really, really big numbers. So if I write the prime factors out first, 18 is, what is that, 2 times 9, and 9 is 3 times 3. So 2 times 3 times 3. 30, that's 5 times 6. So that's 5 times 2 times 3. 6, that's 2 times 3, and 35, that's 5 times 7. If I write the products out first, instead of getting these large numbers, 360 and 180, if I break it down first, then I can just take anything in the top with anything in the bottom, reduce. These 3's reduce out. A 2 and a 2 reduces out. this 3 and this other 3 reduce out, and this 5 and this 5 also reduce out to 1. So on the top I'm left with 7, on the bottom I'm left with 2. Notice I got to 7 halves, the same answer here, without having a whole lot of large numbers at all, right? There's one more way I'm going to show you how to do this. 1830 times 35 over 6, which is going to get you, again, the same answer. If you see that 18 and 6 can both be divided by 6, what you can do is just put a slash through them. 6 divided by 6 is 1, 18 divided by 6 is 3. So I'm basically taking out the number and reducing it right then and there. It's actually even faster. 30 and 35 can both be divided by 5, so if I take 30 and divide it by 5, that gets me 6, and 35 divided by 5, that's 7. So on the top I'm getting 21. 3 times 7 is 21. 6 times 1 is 6. Now that can still be reduced, right? Looks like by 3. 7 over 2. Look at that. It's the same answer done 3 different ways. I just think if the numbers are large, I don't want to multiply the tops and the bottoms. Let's do one more example. Notice the 35 and the 70, they're both divisible by 35 because 2 times 35 is 70. So this is divide by 35, you get 2. Divide by 35, you get 1. 6 and 36 can both be divided by 6. 6 divided by 6 is 1. 36 divided by 6 is 6. And that leaves you with 1 times 2, or 2 on the top. 1 times 6, or 6 on the bottom. This is divisible by 2, and I'm reducing it to 1/3. So that is how you can reduce before you multiply.